Alright, so the plan for today is to try and explore hot reloading in C, and basically what I want to implement is a really simple base game of Tic Tac Toe, and then I want to have different strategies like a random strategy, maybe min max, and I don't know, player input, something like that. And then I want to be able to run the base game with a list of strategies and then 1v1 each strategy and see which one is going to win. And the idea is we'll have a common, I don't know, I guess strategy.h file or something like that, or we'll figure out the name, obviously. And this header library is going to have a single get move function, and the get move function is gonna get as the input the state of the game, like where are the x's, where are the o's, or something like that, and it's gonna give us a move, where to place the next symbol, and maybe which player you are or something like that. And then we'll have multiple implementations for that function, and we'll compile them to DLLs, or in Linux we'll have SOs, or shared objects, I think. And then we are going to load those things at runtime, and we are going to use something called dlopen. And there are quite a few functions here within this dynamic library, I think LDL. We have to compile with LDL, or like dynamic library. And yeah, we'll have to open those shared objects and look for the function. I think it's dl symbol, which gives us the function. So we'll use this library, the dynamic, or what's it called, dynamic linking library, LDL. So that's the plan, right? And we are going to use those shared objects to load in the strategies, and then we'll try to 1v1 them. And I want to start with Tic Tac Toe first, and maybe we'll build up, like maybe Connect 4. It's another, because Connect 4, come on, it's more, you can have more ideas on how to play Connect 4 than Tic Tac Toe. Like for Tic Tac Toe, it's pretty simple. The best you can get with the best strategy is probably a draw. But yeah, so let's do Tic Tac Toe C. And as usual, we start with the flake, and I'm gonna use basically the flake from ds.h, nothing special about it. It just comes with clang and I guess valgrind. I don't think we need anything else. So yeah, pretty much that's it. Let's I mean, I should have downloaded clang beforehand, but it is what it is. I'm not sure if we are gonna need ds.h, but maybe, who knows. I'll try to make it as simple as possible though. So after this thing gets installed, let me just run develop command, and let's start with the simple include stdio.h. This is the main function, and hello world. I mean, it's bad juju if you do hello with lowercase. We have to maximize our chances. So I guess even W needs to be capital, then exclamation point, right? Anyway, so right, let's create our header file first. I think that's a good starting point. So I'm gonna call it maybe like strategy H, like the strategy for the game. And then we have the strategy, if not defined, then we define it. This is just so you don't include this stuff twice. So usually I notice this problem specifically with ds.h. It happened to me like when I really understood this part, because in ds.h, it's a small tangent, but maybe it's worth noticing it. So in ds.h we have this implementation defined, and if this thing is defined, then we include all of this code, right? So if I include this.h in multiple files and I define this thing, then I include the same code multiple times, and then you get function already defined error. So that's the point of these guard clauses or whatever. So anyway, doesn't really matter. Let's think about how our move function is gonna look like. Let's first do move, like simple. So usually Tic Tac Toe is a 3x3 game. I mean, if you don't know Tic Tac Toe, it's kind of weird, but maybe how we are gonna represent it in, because I want to print it in the terminal, right? I want it to be simple to maybe how we are gonna see it. Like imagine this is a game that was played or something. It's gonna look like this. We are just gonna print it. I mean, it has to be like valid. Let's pretend that it was a draw, and usually we used to play this game on our damn, I forgot how you call them, like the notebooks when you're in school and you're getting bored in class and you're playing tic-tac-toe with your friend. So yeah, that's how it's gonna look like maybe. So the idea is we want this move function to get as much information as possible to give the best chances to the player. So why not just have the board as an array, and maybe it doesn't really matter if it's 3x3 or 1x9, like it's the same thing. So we can give it as a 9-dimensional array, right? And maybe we also want char turn. So whose turn is it? Is it the O or the X? Right? And I think we just want the index where we want to write. So it's gonna be a number between 0 and 8. 8 included. So I think that's gonna be the function, right? And usually how we go about implementing this thing, maybe implementing the game first would make more sense, but yeah, it is what it is. Usually we want to include move.h, or I guess strategy, I call it strategy.h, and then we want to define this function. Like that's what we would do usually, right? And let's say this is the random strategy, or I don't know, maybe it's something like it looks in the board and it chooses the first empty spot. I mean, let's do that, why not? So we are going to define index is equal to 0 for index equal to 0, index is less than 9, index plus plus, and then something like if board index is equal to like 0 character, then we return index, and I don't know, return -1 for invalid move. I think that's fair. So this one is just like random, completely random. Maybe we want to do something like void turn, so it's unused. We don't really care about whose turn is it, we just return the next available index. And this is how we usually implement it, right? We include our H file in some C file, whatever. We can have strategy.c and still do the same thing. I'm just gonna use main for now because we are going to refactor this thing at some point. So let's just implement the logic for the game, and the logic for the game is going to call to this move function. That's pretty much the idea. So maybe we want to do something even more interesting, but for now let's just implement the logic for the game, and then we'll try to have different strategies. So first of all, let's have a function that prints the board. That's a good point. So void print board, and it's going to take in a board. I mean, let's hard code all the numbers. Why not? So for int I is equal to 0, maybe let's call it row is equal to 0, row is smaller than 3, row plus plus, and then we have the column. Right, I mean, we could have some defines for these things like width and height, but whatever. So yeah, we get the index, and how do we compute the index when we have the row and the column? Well, you have to say something like row times width, and the width is 3 plus column. That's why I would define width and height, honestly, but you know, it's gonna be 3, so why bother? Okay, anyway. Right, so let's print f character, and I guess we could have some if statement though, because yeah, sure, like if board index is equal to null character, like empty, we should print f space, else we print f the character. So board index, I want to use \0 as empty, and you know, we show it. We could show a dot, we could show empty space, whatever, and then we have to print f a new line, and that's gonna be print board. So let's have char board 9 is equal with all zeros, and then we print board. It's gonna be just empty space. As I said, maybe we want to show a dot in here, but yeah, whatever. Let's show empty space. Now maybe showing a dot makes more sense. Maybe it's you know, you can see that this is the board. Okay, let's keep dots. Why not? Now ideally you would print it nicely with vertical bars and horizontal bars, but come on, like that's way too much. Honestly, you're asking for way too much. So okay, like that, and then we define the turn. So it's usually x starts, right? X starts, and then O is next. Perfect. So maybe we want a function that checks if someone won or something, like a char winner. Board 9. And the idea is we are going to print X if X wins, O if O wins, and maybe null character if no one wins or something. So yeah. How do people usually do this one? Do you hard code all the cases? I mean, that's crazy, hard coding them. But let's pretend that for now it's gonna be return. Oh, right. So obviously we would need a while loop, and then we need to call to this move function. So it should be something like while winner board is equal to 0. So while we don't have a winner, we want to print the board, then we want to get a move, so int index is equal to move. We pass the board, we pass the turn, then maybe we say something like turn is equal to, and then we have turn. If turn is equal to x, then it's O, otherwise it's x. All right, so we swap whose turn is it, and then we say something like board. Well, maybe first we say board index is equal to turn. Oh yeah, turn. So we set that into the board, we mutate it, and then we swap the players. So I think that's pretty much it. Maybe we want to print the board afterwards, right? Maybe here's something like if index is equal to -1, we break. So if we run this thing, we should see that the board fills up, right? But x won at some point, right? So we didn't check for that. So we have to implement our winner function now at this point. And yeah, if you get index -1, it's kind of bad. So yeah, maybe I want to do something like return 1 or something. Anyway, whatever, it doesn't really matter. So let's try to implement a win function. So we have to check all the lines, all the columns and the diagonals, right? So let's see. How do I want to implement it? So maybe just row is equal to 0, row is less than 3, the usual, right? We iterate all the rows, and at this point I'd say we want to take the symbol from the first column of this current row, and I guess char, let's call it turn, or I mean player, whatever, it's the same thing. And then we say something like we also need the index. So index is row times 3, which is the width. So the turn is board index. Right, it's like plus 0, right? But since it's plus 0, we don't really care about it. So we get the turn. If turn is the null character, we don't care about this row. It's like you cannot win if the row is empty. You cannot have 3 consecutive characters, right? If the first one is empty. So that's that. Otherwise, we could have a for loop. Column is equal to 1. Column has to be less than 3. Although I guess the easiest thing to do here, because we know there are only two other columns, we could say something like if turn, well, we don't even need turn, honestly. We could just say if board index is equal to board index plus 1 and board index is equal to board index plus 2, then we just return board index, right? Like this guy just won. And then we can have the same thing for the column, or similar, but in here the index is gonna be a bit different. It's gonna be just column because it's 0 times 3, because the row is 0, plus column. So int index is gonna be just that, just column. So if board index is 0, then we just continue. That one is you cannot win in that case. And then we have to check board index and here we need to do plus 1 times 3, right? So plus 3, and board index is equal to board index plus 2 times 3, so 6. So if this thing is true, then we just return board index. And for the last case is the diagonals. So for diagonals, honestly, I'm just gonna hard code them. So I guess if board 0, I mean, you have to go with a negative case. So if it's not equal to 0, okay, and board 0 is equal to board, I mean, you'd have to say 1 times 3 plus 1 to go 1 1, right? So it's 4, and then is equal to board, and on the last diagonal it's 2 times 3 plus 2, so 8, right? Hopefully it makes sense. I mean, I want to do and board 0, then just return board 0, which is the same character, and then we have the other diagonal. I mean, obviously you'd if you want to implement it with 10 whatever, you do 2 for loops, and the main diagonal is when the row is equal to the column, so 0 0 1 1 2 2 and so on. And if you want to go with the second diagonal or whatever it's called, it's gonna be what? It's gonna be I plus row plus column is equal to n or something like that. Was that it? I think it's something like that. Row plus column is equal to n minus 1 maybe, or something. Yeah. So anyway, it doesn't matter. We know that we are looking at the other diagonal, so let's start with the first row. So on the first row is gonna be board 2, and then 4 it's in the middle, again that's fine, and then board 2 is equal to board I guess it's 5. No, it's 6. It's, yeah, so it's 2 times 3 plus 0, right, for 6. And we return, oh, I was, okay, yeah, whatever, let's put it here. So yeah, this should be, and then on the else case we just return 0, as in no one won yet. So if we run this thing, you see now it ends when x first wins, right? So that's the idea. And let's have a function though. Maybe we are going to call it simulate. Right, and the point, well, the funny thing is, let's have something like int print. If print, then we print the board. So the funny thing is, I was thinking that if there is a winner, the winner is gonna be turn, but if there is no winner, then what are we gonna do? Maybe I want to do something like a char winner board, or maybe, you know, there is no winner initially, so it's gonna be 0, right? And then win is equal to winner board. So we just return win. Well, I mean, here I want to break. Okay, so now we have simulate, right? So if I call simulate and we say 1 because we want to print, then we get the same thing, which is pretty cool. You know, I would do the deleting of the previous terminal stuff, but let's keep it like this. Maybe in print board I want to also print f here, another new line, just to get rid of like to have some extra space in between each game, or like each board. So yeah, that's it, and I think that's pretty nice. Now the thingy, right? So we have this move, and I said maybe it would be cool to have multiple move functions, right? That would be kind of interesting. So one thing I'm thinking about, let's go to strategy, would be to probably type def a function, or like have a pointer to a function. But the problem is, see, pointer to function. I honestly, I don't remember how you write that. So something like this. Whoa. The fuck? Cannot I copy? Okay. So let's say move X, right? And here I want char. Can I do something like that? feels a bit weird. And char. So this would be a global variable, right? But would be even more interesting to type def it somehow, like move t maybe, and then we can have move t, move x, and then move t, move o, right? That I think that's allowed. And let's put it here. And initially these things should be null, right? I think that's still working. And let's say that instead of calling to move directly, we are gonna do something like if turn is equal to x, we are going to say move x more than turn. Otherwise, we are going to say move o. And obviously it's gonna segfault because they are null, obviously, right? They are null. So what we could do is just say, okay, move x is gonna be move, and we use reference, and move o is gonna be move. Nice. So still works, right? And now what we could do is just implement another move function. But see now, the problem that I have with this is you implement all of these functions in the main file. You don't implement them, I don't know, outside. So if you want to have like inject a function, like someone else implements you know, custom AI for this game, they would have to commit it into the main.c file, which I mean it's not bad, but would be more cool to be able to load it from a DLL or something like that. That would be cooler. But let's, you know, so this would be the classic method of you implement a function for each AI and then you use it like this maybe. Right, you have two variables like pointers to functions, right, and then you assign to each one a different thing. So for instance, let's say that move one is and I mean, yeah, the turn doesn't even matter at that point, I guess. Maybe it didn't even matter the turn, but whatever. Or maybe, you know, yeah, I guess for min max it matters because you want to know who you are. Like this is just random. And then the other one is what if I want to read a symbol? So let's have something like int index is equal to 0, and then I do scanf. And how do you do that? Index? But obviously, you know, it has to be empty. So if you have to go like that, and int I, well, maybe it's just like that, and then otherwise you return -1 because you are dumb. So now you see it waits for your input. So if I say 1, it's going to put that there. Now what should I say? Let's try to put it here. So it's 0, 1, 2, 3, 4. and then he's gonna put it here, and I can put it here, right? So that's the idea. 0, I have to count it. I think it's 7, and just beat the simple AI. Maybe we want to display something like if print, we can have something like if win is 0, printf the game. Maybe you can just say draw if win is, come on, we can do better. And then we have else printf %c 1 backslash. So if I do 1, press enter, 1 4 and 7 0 1, and if I try to do a draw, or if I try to lose 1 3, I think it's 5 x1, and then let's try to do a draw. I have no idea how to do a draw against this thing, but let's try. 3, okay, I think I have to do 5. Oh wait, no, 5 was the losing one. 3, 6, and then 8, and that's a draw. Why did it wait for my input again? Oh, I guess it makes sense, right? Because of how I implemented this thing. Yeah, I guess the other thing I can do here is maybe just, if there is no other empty space in this thing, we can just break. But yeah, whatever. Let's pretend it works, right? So that's pretty nice. You know, you can have different strategies, but you implement them in the main.c file, which kind of sucks. It would be cooler to send the strategy name as arguments and then load it from different files. So let's try to do that now. Right, so let's call this one player.c, and let's just copy paste the strategy. We include this thing, and let's take this stuff, and maybe we need stdio. Right, so this one is the player strategy, which just reads the input from the player. All right, we can delete it from here, and maybe the other one is gonna be sequential or something like this one. And I would still keep, actually I don't know, let's call it sequential.c, or first. Let's not be too excited about the names. Okay, so I think we don't even need strategy.h in here, to be honest. I think we just need to define the type of of the function, right? So we know we are going to expect something like this in our DLL, and these are the global variables for that function. Right, now sure, maybe I should have something like int full and then board. Like this would help maybe with other strategies. So int is full, whatever is 0, I equal to 0, I is less than 9, if board I, like this is just a small tangent, it is what it is full is 0. Okay, so it has to start with 1. Okay, so return is full, whatever. So if it's full, we just break sooner. That's the goal. So here, instead of asking for input, we just check if the board is full. We break one step sooner. Like we don't need to ask for this stuff. Okay, so now here it complains, obviously. And I said we are going to need dlopen. But first, no, I mean we have to compile the. No, let's keep dlopen. We would need to compile the player strategy and the first strategy into DLLs or shared objects. So usually we do something like let's do the player C player.o, and usually we compile it directly into an executable, but sometimes maybe you saw me compiling it to object files with -c, and I guess one step further is to compile it into I mean into A, which is static. But now we are going to do, I think it's -shared, and I think you also need fpeak, so position independent code. I'm not sure if you need anything else for libraries. I mean, it has this warning, but I don't think it matters. So this scanf, I think it returns return like status code. So maybe we can do something like if it's less than 0, return -1, but I don't know really what it returns. Whatever. So we get now an SO file, right? Which is like a DLL. So you can link with it. I mean, maybe a good example or a better example would have been, but I mean, I already explained that. So, when I said that in here we were writing the function move, but at the same time, we could have refactored it into another file and compiled it from 2 files. You can do that in C. Yeah, but anyway, so we created this player SO file, but I think you need to call it, I think you need lib in front of it. Other than just from school, what I remember is that usually you need lib in front of the lib name. So when you link it with it, it's gonna be L player or something like that. But anyway, so that's how we compile player.c into a DLL, right? Oops. And you see here we don't have a main function, it's just a single function like a library. And cool thing, include strategy.h would be that, I mean, we can still compile. So let's say clang -c main.c main main.o, obviously, and then I'm pretty sure we can say something like main.o L player, which is the library, and compile it into O, but I think we also need to say something like capital L dot, so search for the player library in the current, but I thought that's default. It's not. And here it complains that it cannot find shared object, and for that you need to export library path and then run main. And now it's actually player versus player, but yeah, so it's the same thing as we had before, but we split it into two files, right? So we still don't load these things at compile time or like at runtime as I would like, because that would be cooler to be able to load this thing at runtime and have different strategies. Right now we have the same strategy, so we can just remove strategy.h. We don't need that. And what I'm gonna do now is actually let's try to use dlopen. So dlopen, it uses the file name and some flags, and it returns a handle. Okay, so let's try to see what happens. So void pointer, let's call it player, and let's do dlopen. And to be able to use dlopen, we need dl function or whatever. So we need dl function. So let's say dlopen, and I'm gonna say here lib player.so maybe, and for the flags we have the option between lazy and now. I guess lazy is not going to resolve all the symbols until you ask for them, so that's maybe useful for big libraries, but now would be fine. It's like, do you want to have some overhead at startup with now, or do you want to have overhead when you call to the library? So it's like, if you know you have, I don't even know, if you have a lot of calls, maybe you want, I don't know, if you use rtld now, it's going to have some overhead at startup, but that's fine. It's like one function, so who cares? So that's how we start this thing. And obviously this can fail, so maybe we want to have something like if player is null, then we print something. And I'm pretty sure this has some special functions to display the error. Oh, nice. So I can just copy paste it. It's a good thing they have an example. Oh, so you have to call randomly to the error. Yeah, whatever. And then exit failure. But since it's main, I'm just gonna say return 1. So let's see what happens with that. Okay, and then we have to use dlsim to search for a function. And the function that we want is called move, and the handle is player. Okay, and what do we do here? It's casting it to our type. So I'm just gonna say, no, we don't even need that. And let's use the same thing. I mean, even this thing can fail, right? Am I right? The following workaround. Whatever, I don't really care. And at the end we dl close the handle. So let's I suppose we do it here at the end. Yeah, I know, and this, if this can fail, then we use the same thing. So if move x is null, we fail it, and then if move o is null, we fail it. Right, so if let's say we just recompile this thing, we recompile first into lib first.so, and let's try to compile our main function. So we no longer need this thing because we don't link with libplayer, but we need to link with dl, which it says it here, right? We have to link with ldl, dynamic linking library. And if we run this thing, undefined reference to move, oh, I'm compiling the O file. Okay, so it compiled, and yeah, obviously it's not gonna work because we need to run it with ld library path, right? But now it works. So the cool thing would be to be able to load different SO files, and as I said, 1v1 them. So let's do first, which is gonna be lib first.so, and I'm gonna first, then we have the player, then we have move x is going to be from first, and move o is going to be from player. And if I run if I compile this thing again and run it, you can see that I am moving the o and the x is moved by the first strategy. So that's pretty cool, I would say. And yeah, obviously the next step maybe would be to have a list in the arguments and do like a tournament between different strategies. So yeah, and we need to also dl close first. But I think that's pretty cool. Maybe just adding the last strategy, which is I mean, the most important one is min max, but let's do random. I'd like to do random because it's going to use math, pretty sure, or I mean, it's in stdlib. Okay, so it's not really. Wait, why doesn't it work to copy paste from that? Okay, anyway, so I'm not gonna use srand. I'm just gonna do random. So I guess the easiest way to implement this random thingy would be something like having something like int count is equal to 0, and here count increases if we find an empty board cell, right? And obviously we don't need the index, right? And then at the end here, if count is equal to 0, we return -1. Otherwise we do random modulo count, right? That's the easiest way to do that. And I guess doing this srand thingy first thing in main maybe helps. But yeah, so as I said, I think arg c, let's see, arg b. So if arg c is not equal to 3, then we are going to say something like printf usage main whatever lib1.so lib2.so new line return 1. So we print the usage, right? And in here I'm gonna say argv1 argv2, and maybe instead of player I'm gonna say strat2 and strat1. So the first strategy, the second strategy, and that's that. Right, so clang, let's lib random.so, and if we compile main and we run it with lib random.so and lib first.so, oh, I have to add the path. See, it's running random against first, which is kind of cool. So it's gonna be pretty random who wins and who loses, but it's, oh, you know what, I'm the random one got me. So you can make illegal moves. That's pretty funny. This is the index actually, and what I have to do is go from I to 9, and here if int, let's just say count is equal to 0 again. If count is equal to index return count and count plus plus, so somehow -1, but that's kind of impossible. So we are looking actually for the end empty space, not the end space. That was a small mistake, but it's fine. So we have to recompile the random library and then we can just run it, right? We don't have to recompile main. That's the cool part. Wait, how is it a draw? Fucking stupid. Um, oh, I. Again, you just need to recompile the thing. I mean, it's, you know, it's extremely scuffed because you can make, I mean, it still makes illegal moves, right? Damn. Maybe having some fail safeties, like safety checks in here. So if you make -1, then it should be some kind of error. It's getting disqualified basically. So if you have, if you've made -1 and the board is not full, it means it's an error, right? Or maybe even here, or board index is not 0. We can have something like printf, and then we put the character for the turn, made an illegal move, and this gets printed, right? And then we return the other way around, so we give the win to the other guy if you make illegal move. And for now, for that we have to recompile main because main changed, right? So here you can see X made illegal move, so random still sucks. So we have to make sure that it doesn't make an illegal move, but at least now we catch it, right? So inside of random, what the fuck did I do wrong, bro? So here we count how many empty squares we have. It's pretty obvious, pretty simple actually. Let's just use I for the index. So this is how many empty squares we have. If we don't have any empty squares, then I mean -1, you cannot make a move. Then if we take a random index in between 0 and how many empty squares we found, it's pretty fair to me. Then we iterate again the squares, and if it's an empty square, fucking stupid, I have to return I. So if we find the given index, then we return I. Okay, that's what I wanted to do. So let's recompile librandom and let's run it again, and now it should not overwrite anything, and you know, we get librandom.so. We should get a bunch of different results if we play randomly, which is kind of cool. Okay, and obviously the last one is minmax.c, but honestly it's I have no idea how. I'll admit it, I have no idea how to implement minmax or Tic Tac Toe. I still think it's pretty neat how you can have something like this where you know, because you can ask someone, okay, let's make like let's have a small competition, and everyone implements their own strategy and it's just the move function. And you can even have stuff like, okay, it has to be smaller than 1000 characters, like you can only use a certain amount of space. But I mean, the certain amount of space kind of sucks because I mean, non-white space maybe, like you can use however much white space you want. But yeah, so yeah, no, something like that. That would be pretty interesting. And then you give them the strategy.h file and they have to implement the function. So that's kind of cool. But yeah, I have no idea how to implement min-max, I'll be honest. Let's see. So we give it an example. Let's see if Copilot knows how to implement min-max. Use min-max for Tic Tac Toe. Pretty interested. Let's see. Holy, it's huge. Holy shit. Okay. Okay, so it still needs this winner. How the fuck does it know these functions exist? It looks in my project. It's collecting my data. So it obviously it might need this winner function. It makes sense, right? Because it needs to look into who is gonna win, right? Because if X wins, if the enemy wins, then, but here, you know, it's like we use turn. So if X wins, it returns 1. If O wins, it returns -1. And if the board is full, it returns 0. And then we have best score. If turn is X, it's -2, 2. Honestly, I thought that this should be something like if let's actually see, maybe it's wrong because it doesn't feel right, honestly. So in here it makes sense. What we want to do is simulate updating the board, which I think it's fine to change it because it's not sent by reference, it's a copy. So, and this one is it made it into a min-max function. But now how do I actually use this thing? So if I make move, okay, let's see. So the min-max should return a score. That's obviously that's true. And you know, it makes sense to me that first we have to call the winner and see if we have a winner, right? And if the winner is X, but I thought you also need, like, if win is equal to turn, then you have positive value, and otherwise you have negative value. That's weird. Then for best score, that's also, it's weird. Why? Then sure, it makes sense to iterate all the empty cells, right? We update, like we recursively try to update this board I, and then we call min-max with the enemy's turn, basically. Sure, it makes sense. Then we just reset what we set there, and if the turn is equal to x, then we set best score either to score or best score, otherwise we do the other way around. Maybe it makes sense, I don't know. And then for the move, we have to call min-max on each one, and if the score is better than I guess best score, we save the index. No, somehow it makes sense, honestly. Maybe it works. Let's see. So if I go into main.c file and I just copy paste winner and full, if I just copy paste winner and full, this should compile, right? And maybe that's the other thing. Maybe I would want to have a tic-tac-toe.h file, which everyone that implements a strategy can use. It's like the game engine, so to speak, that anyone can have access to, right? But yeah, whatever. I mean, I'm still, you know, min-max pretty. Honestly, this feels like the most difficult algorithm to understand for me, the min-max one. Maybe we can do more things like this, like maybe connect 4, because it involves more min-max, I think. And what about like a small chess game engine, like that? I mean, that's a lot more min-max if you want to go that route. So we can try that. Try to become better at min-maxing. So let's try to compile. So minmax -o lib minmax.so. And now if we should see that O wins most of the time, or at least it draws. Right, like X should never win. That's the, and if we run min-max against min-max, it should always be a draw. Interesting, it's always the same result, but I mean, it's always a draw. No, it's pretty cool. Yeah, I really want to understand better min-max because it's pretty cool, but yeah. It wasn't really about min-max in this video, so that's why I just went over it like that. It was more about trying to figure out if this thing is going to work, and you know, preparing for next time for a cooler example, like what about Connect 4 or chess. So that would be way cooler. But and maybe even adding graphics, because right now it's just CLI. But yeah, I mean, it's really cool, right? You are able to run this thing with different strategies. Let's try to beat min-max. We are going to get beaten. Let's do 2. It goes for the kill. It's 6, I think. It blocks. Oh, and I got smoked. That's I mean, pretty nice. But yeah, random against min-max, not even a chance. So yeah, I think that's a pretty cool result, right? So we can load DLLs or SO files at runtime and then look for functions. So this is pretty nice. We might be able to just implement something like a 1v1 arena for some kind of game where you have to optimize, like Connect 4. That's an easy one to figure out. It's like Tic Tac Toe, but a bit harder. And you know, the main goal would be like a chess 1v1 thingy, and be able to take DLLs from different people and try to run them together in a competition and see whose bot is the best. Although, you know, like, so yeah, I think that's pretty cool result for now. Which, pretty happy with it. So, you know, if you enjoyed, don't forget to subscribe and like, and maybe even comment some ideas. So yeah, see you in the next one. Bye bye.